everybody, thanks for watching. This video is going to give you a chance to practice creating ionic bond models for different sets of metals and nonmetals. Remember from the last video, I gave you a few simple steps for how to create these models, starting with electron dot diagrams, followed by drawing in arrows to show the transfer of electrons, adding additional atoms if you need, ending with the resulting ions and their charges. For our first different example, let's create one of these models for the ionic bond between magnesium and fluorine. So the first thing we have to do is draw the electron dot diagrams for each atom. From our little shortcut in the last video, magnesium is here with 2 valence, and fluorine is in this column with 7 valence. So I have 2 for magnesium and 7 for fluorine. I'm also going to put the full electron configuration beneath each atom. You don't have to do it, but it is going to remind us why these atoms are bonding together in the first place. The next step is to draw in arrows to show the electron transfer. Now remember how this works. The metal is going to be trying to lose whatever valence it has, so magnesium is trying to lose 2. The non-metal is trying to gain any valence for the empty spots that it has, so fluorine is trying to gain 1. So all I have to do is start drawing arrows from magnesium to the fluorine into whatever empty spots that it has. That brings this fluorine from 2p5 up to 2p6. It now has a noble gas configuration and is stable. The problem is magnesium still has an extra valence to lose, and this fluorine can't take any more. When you run into this problem, there's one simple fix, and that is just add in a second fluorine. If you're wondering how can you do that, just create atoms out of thin air. Just realize that if this was happening in real life, there'd be lots and lots of magnesium and fluorine atoms, not just one of each. So you can add in as many as you need. That gives magnesium's second valence a place to go. This fluorine has filled up its empty position, and the magnesium has lost both of its valence, bringing all these atoms to noble gas configurations, making them all stable. Once you've completed that, the only other thing is to draw what each of these atoms turns into after the transfer. Magnesium gets a +2 charge. It's our cation. It's a +2 because it lost 2 electrons. We use 2 fluorines, so I like to put a big giant number 2 in front of the fluorine symbol, and each of those fluorines gained 1 electron, so they have a charge of -1. The formula of this compound, if you had to write it, would be MgF2. That little subscript 2 is telling us that we needed 2 fluorine atoms. And that completes the whole model. Let's take a look at another one and try and draw the model for the bond between lithium and oxygen. I also recommend that if you feel like you get it, you pause the video and try it yourself before watching the correct answer. Here's what it should look like. We start off with dot diagrams. Lithium has 1 valence, oxygen has 6. Meaning that lithium has 1 valence to lose, and oxygen with 6 has 2 empty positions. So it has to gain 2 extra valence electrons from the lithium atoms. So my lithium transfers its 1 valence to the oxygen. Now lithium has a noble gas configuration and is done, but oxygen isn't. So remember our fix from the last example, just add in another lithium with its own valence that now gives oxygen a place to get an electron from. My oxygen has filled all of its empty positions, has a noble gas configuration, so does the extra lithium that I added. All the atoms are satisfied and stable. Finish it off by drawing what each of these atoms turns into after the transfer. I needed 2 lithiums, each is +1 because they lost 1 electron, and 1 oxygen with a -2 charge because the oxygen gained 2 electrons. The formula, if you had to write one, would be Li2O. And finally, pause the video to see if you can create a model for the bonding between aluminum and bromine atoms. Aluminum has 3 valence and bromine has 7, so aluminum will start to transfer its valence to fill up the bromine. Bromine only needs 1, however, and aluminum still has 2 more to lose, so I need a second bromine for that valence electron on top, and a third one for the valence electron on bottom, and finally all of these atoms have noble gas configurations. After the transfer, they turn into aluminum +3, and 3 bromines that are each -1, the formula being AlBr3. And that concludes the examples in this video. Thanks for watching.